the science period, chapter 14, electric current and its effect. Today is the fifth part of the same chapter. Children, yesterday during the period we discussed about the magnetic effects of the electric current. We talked about the electromagnet. We talked about how the current is related with the formation of a magnet, how this takes place, and how many of the devices they work with this magnetic effect of electric current. Children, what is magnetic effect of electric current? When an electric current passes through a wire, it behaves like a magnet, and this is called the magnetic effect of electric current. Electromagnet is a current carrying coil of an insulated wire which is wrapped around a piece of iron is called a magnetic electromagnet. All this we discussed yesterday. Then we saw some of the devices which are based on the magnetic effect of the electric current. Among them we have our mobile phones, cranes which are used in the dump yards, your loudspeakers, electric bell, your toys, refrigerators, as well as the television. So today, children, we will be studying in detail about the electric bell. That means we will be seeing how an electromagnet works over here, how an electric bell works with the electric, and it gets changed up into a magnet. So here you can see the entire figure of a electric bell. You can see the bell, you can see the adjusting screw, soft iron armature, spring, coils of the iron core, here you can see, and then you can see the spring which keeps on moving. This is the, just a minute. So here you can see the bell, then you can see the contact which keeps on hammering over here. This is the adjusting screw, your armature. This is the spring which keeps on moving, and this is the coil soft iron core which will be behaving like a magnet. So children, now we will be studying the working of an electric bell. When the switch is on or it is pressed, the circuit is complete. When the circuit is complete, the current starts flowing through the wire and the coils become an electromagnet. Here you can see how the coil, when the current is being transferred, either when the current starts flowing, here we have switched on. Okay, this is your switch. So we have switched it on. Now what is happening is current starts flowing. This is becoming electromagnet, and then this starts banging, and you can see here the bell. So this is the working of an electromagnet of a electric bell. Here again you can see the structure of the same in a circuit form, how it is working. Here you can see in the first figure, here you can see this switch is in off position. Okay, so that means it is not working. In the second one, it is in the on position. The switch is in the on position. So whatever we have just now seen, how the coil has started turning into an electromagnet, and how this hammer keeps on beating the bell. So this is all you can see in these two figures in a separate way. The tiny iron hammer, which is attracted by the electromagnet, strikes on the bell. As the hammer moves towards the bell, the circuit is broken and the electricity stops flowing through it, and so the coil loses its magnetism. Once the bell is hammered, as soon as it is hammered, the circuit is broken off, the electricity stops flowing through it, and the coil loses its magnetism. As the coil loses its magnetism, the hammer returns to its original place, and this completes the circuit, and the electric current again begins to flow once again. So that means as soon as the hammer returns back to its position, the circuit is complete, and then the current starts flowing. So this is, here you can again see the structure of your electric bell. So I hope it is very clear to you how it is working. As the electricity flows through the circuit, the coil acquires the magnetism, and so the hammer strikes the bell again. This circle repeats. This cycle keeps on repeating itself, and the bell continuously rings as long as the switch is kept pressed. As soon as the switch is off, it stops working. I hope children you have understood the working of the electric bell. Now we will be just recapping the entire chapter once again, so that we will be just highlighting few of the important topics over here. So first one, an electric circuit is a loop which is formed by connecting a source of electricity with an electric appliance in a definite manner with the help of the wires. So here you can see a circuit shows the arrangement of the different components of the circuit. So when a circuit we talk of, so here as you already know, there are various components. We have the lighting of the bulb, okay, either you can say the light bulbs, then we have the wire, we have the switch, we have the source of energy, that is your cell. Okay, so here you can see four things. Once again I will repeat, this is your wire, this is your switch, this is your cell, and this is the bulb. So as soon as the switch is on, the current flows and the bulb is glowing. Here you can see the same. There I showed you with the components, and here you can see in the form of a symbol. So here you can see it is a battery shown over here, and there I have shown you the cell. So if I am talking of a cell, it will be like this. Okay. So you have to remember that only one cell means one, and battery means two cell. And here you can see the structure of the bulb, but if you go for your own, the structure of the bulb is like this. In your book it is given like this. So this is the structure of the bulb, but you can go for this type of symbol also. Here the switch is in off position, that means the circuit is incomplete, so bulb will not glow. I hope it is clear to you. This is the circuit diagram with the help of the symbols. Now what is a fuse? The next important thing, it is a safety device which prevents the damage of the electric circuit and the appliances by breaking the circuit when excess of the electric current enters the circuit. So when the current is flowing, and if excess current flows within the circuit, it stops it so that there is no damage within the appliances. Nowadays we are using the MCBs, and even the cartilage fuse has been used in many of the devices so that it can be stopped there only, and we can protect our electrical appliances from the damage. Here you can see again the structure of the fuse, MCB, and your cartilage fuse. Now the heating effect of the electricity is basically produced within a wire, and it depends on the following. First is your material, type of the material that you are using for the wire, length of the wire, and the thickness. Here few appliances where you can see how the heating effect is visible when we switch on the our appliances. So today we studied about the electric bell. We talked about the simple electric circuit, the heating effect of the electric current, as well as the magnetic effect of the electric current. Children, your home assignment, you will be writing the working of the electric bell. You will be drawing a well-labeled diagram of an electric bell. So this is the homework, and in this way we are able to finish off with the chapter. Hope so that you have understood the chapter. Here you can see few of the uses of electricity in our day-to-day life. So here they have shown you that electricity is used in different ways. First is motion and power. So here you can see your car, motors and many other vehicles. The other one is your heating and the cooling effect. So here you can see your oven, iron, refrigerators, televisions, all that. Then we come down. Here you can see how the light, how we use electricity for the production of the light. Then here we okay, so here you are using your laptops, your mobiles, your radio, your phones and your TV sets. So in these different ways we are using the electricity in our day to